Hey guys, it's EJ with Blockpad, and today, as part of our video series on arrays, we are looking at creating arrays. So to get into it, let's look at brackets, which is how you're going to input an array directly into an equation. So here, I'm using semicolons between each item, and that's going to mark the end of each row, and so start a new row. And when I only use semicolons, that's going to create a one-dimensional array that is vertical. Now, if I use commas instead of semicolons, then that's going to make a one-dimensional array that is horizontal. For most applications, the difference between a vertical and horizontal one-dimensional array isn't really that big. There are a couple situations where it matters, like concat rows or concat columns, but for most cases, they're going to be the same. Now, for a two-dimensional array, I'm going to type in commas between each item in a row and a semicolon to mark the end of a row. And so in this case, you're really expecting all of the items in a row to be the same number for each row. And if they're not, so for example, if I delete out 5 and the comma with it here, then I'm going to get a null at the end of that row. And the number of columns is going to be the row with the highest number of items. So also I can come back here and delete 8 and 9, press enter, and I'm going to get nulls at the end of that as well. I'm going to press Control Z to get back to my original. So arrays in Blockpad can contain any type of value. So you can have numbers with units, you can have text, you'll just type it in with these quotation marks. You can have arrays inside of arrays. So here I just have these single dimensional arrays with 2 items that I've created with commas and brackets. You can also have functions inside of arrays. You can either type them in as inline functions like I have here, or you can type in named functions just without the parentheses. And you can also have dates as we have here with the dot notation that we've covered in our dates video. Moving on, you can create arrays by referencing table cells. And I say create arrays because I think that's a good way to think about it. But in reality, you're just creating another named value and sort of naming that table range. Because arrays and table ranges in Blockpad, they're going to be interchangeable in almost all circumstances. So for example, down here, I have this table range, table1.b1 to c2, and I'm doing matrix math with it just to show that you can use these table ranges instead of arrays, but typically I find it best to name them like this and to think of it as a way to create an array. Also, a good thing to know when you're creating these, I have d equals, and I can use click to reference, so I can click and drag and press enter just like a regular table reference, and then I'm going to get that array displayed like that. You can also have these horizontal arrays or two-dimensional, or you can reference just the table. So here I have table 1, and it's going to use that whole table 1. Similarly, I can use table 1 inside of a formula, and it's going to work just fine. Just like with regular arrays, any value type can be in a table cell, and so in the array referencing it. So here I have a formula. I have to press the equal sign to generate an array, but in this table cell, I have the array 2, 3. And so when I reference it here, I have my array of arrays. These references work from a spreadsheet and not just tables. So here, this is metal props.a1 to d4, and that's referencing this spreadsheet that I have as a separate frame. So going back to creating arrays, the final point I want to make in this section is that this works both ways in a certain sense. You can take an array and use that to populate table cells. So here, if I double click, you'll see that all of these cells are just the array F. So I scroll back up, show you guys, it's just this array F here that's populating these table cells. I'll press escape. To show you guys how to do that, I'm going to press delete, and I'll press the equal sign again and type in F and just press enter. And when I do that, it's populating just this cell with that array. And so now I can reference that cell, and that's going to be that array. But that's not what I want to do in this case. To populate the cells, you're going to input it and then hold Control Shift and then press enter. And then that's going to populate those cells. And you can format these cells like regular and do, just kind of just about whatever. You can press the equal sign and reference them, and it's going to reference that item in the array. This is also going to be the best way to display large arrays. So like if it's got more than 10 rows or columns, this is going to be the best way, except you're probably going to want to do it in a spreadsheet, not in a table if it's really, really big. So moving on, we have functions that you can use to generate arrays that follow a pattern. So the first one of these is LinearSeries. If you just type in two inputs, then it's going to be the start and the end, and the step size is going to be 1. So I'll press enter. And you can also put in an optional third input of step size. And it's important that the start and the end and the step all have matching units. They don't have to be the same exact units, they just need to be compatible. So for example, if I just type in not 100, if I type in 1 here, then I'm going to get an error because that doesn't work. I have to type in 1 centimeter or 1 inch, or as I had before, 100 millimeters, and then now that's going to work. LinearSeries function has this special display where it's going to show the start plus the step, and the end. And if you want to see the entire array, the best way to do that is going to be with the display in a table like I showed you earlier. So just to show you guys how to do that, we're going to come here to a new spreadsheet. I'll press the equal sign and navigate back over to here and click this array. If I just press enter, then it's going to show this little display like this. But if I go back into the equation and press Control Shift enter, then it's going to display that entire array in this spreadsheet. Moving on, zeros and identity will generate an array of a given size. The zeros function will generate an array with all zeros. This also has a bit of a special display that the show result isn't going to show unless you turn off show formula. So here, I'll change show formula to no, and then I see that that's going to be my result. I'll press Control Z. For identity, that's going to be the identity matrix of the given size. So I can type in 3 here, and now it's going to be a 3 by 3. The most general purpose function for generating arrays is the MakeArray function. Now, with just 2 inputs, it's going to give you that many rows and that many columns of null values. So null values are essentially like blank cells in a spreadsheet. This can be useful in some cases using inline programs or some other stuff. But for the most part, the utility in MakeArray comes from using the third input, which is a function. And here I have that as an inline function. I'll put a link in the description to how to use inline functions. But the arguments to these inline functions are going to correspond to the row indexed to 0 and the column indexed to 0. And there's a number of good ways to use that. A very useful one to know is that if you want to populate an array with just the same value for every item, then you type in these parentheses R, comma C, close parentheses, the maps to operator, and then the value that you want. And then what will happen is these arguments just get ignored, and for each item, it's just going to turn that value right there. Now for this inline function, you can use just the row as I have here. And remember, this is the row indexed to 0, so it's 0 squared, 1 squared, 2 squared, 3 squared. Or you can use just the column as I have here, so I comma j, j is going to correspond to the column. Or you can use both, like I have here. And there's a ton of different ways you can use this. So as an example, say I want an array that is an array of the coordinates of each spot in that array. That's going to be something that I can do using MakeArray. So I'll make this a 5 by 5 matrix, parentheses r comma c, maps to. Now I want an array to show the coordinates. I'm going to do r plus 1 because I want these indexed to 1, and c plus 1, and then close the brackets, close parentheses, press enter. And now I've got this array of coordinates. So 1, comma 1 for the top left, 5, comma 5 for the bottom right. And that was just done using the MakeArray function. Now that's all I've got for you guys today on creating arrays. I'm going to put a bunch of links in the description about creating arrays and about using them. I'll also put a link to this file, which I'm going to use for all of the array video series. So you'll see information on math and indexing, all of that stuff that we will have in the array series. So that's all I've got today. Let me know if you have any questions. Thank you.